In this question, we have to find the focus of the parabolic reflector whose diameter is 20 centimeters and which is 5 centimeters in depth. Let's begin with the solution. And first let us draw the parabolic reflector with the given data. So this is the rough figure of a parabolic reflector. Now we know that the equation of the parabola is y square is equal to 4ax, and from the given data we notice that the point with coordinates 5, 10 will lie on the parabolic reflector, that is point with coordinates 5 and 10 must lie on the parabolic reflector according to the given question. And since we have considered its equation as y square is equal to 4ax, therefore this point will satisfy this equation, that is 10 square is equal to 4 into a into 5, which implies that a is equal to 100 divided by 20, which is equal to 5. Therefore, the focus of the parabolic reflector is the midpoint of the given diameter, which is at this point, and this point is given by 5, 0. Since this distance a is 5, therefore the focus is given by 5, 0. Or we can say the focus of the reflector is at the midpoint of the given diameter, right? So, this completes the solution to the problem.
In this question we are given that an arch is in the form of a parabola with its axis vertical. The arch is 10 meter high and 5 meter in width at the base. How wide it is 2 meter from the vertex of the parabola? Let's begin with the solution. And first let us draw the parabolic arch with axis vertical. Let this be the parabolic arch, which is 10 meters in height and 5 meters in width at the base, and its vertex is at the intersection of the coordinate axis. So its coordinates are 0, 0. Let us denote this point by A. Then this implies this distance is 2.5 meters. So the coordinates of point A are, here the x coordinate will be 2.5 and the y coordinate will be -10. Now this parabolic arch opens downwards, therefore the equation of the parabolic arch is given by x square is equal to -4ay. Let us denote this by equation number 1. Now this point A lies on the parabolic arch. Point A has coordinates 2.5, -10 lies on the arch. This implies that this point will satisfy equation number 1, that is replacing the value of x by 2.5 is equal to -4 into a into y, that is -10, implies that a is equal to 2.5 into 2.5 divided by 4 into 10, and this is equal to 625 divided by 4 into 10 into 100. This is further equal to 5 2s are 10, 5 into 125 is 165, and 25 4s are 25, 5 is 125, so this is equal to 5 upon 32. Therefore, the value of A is equal to 5 upon 32. Now, substituting A is equal to 5 upon 32 in equation number 1, which is x square is equal to minus 4ay. So we have x square is equal to minus 4 into a, that is 5 upon 32, into y. So this implies that x square is equal to minus 5 upon 8y, denoting this by equation number 2. Now we have to find the width of the parabolic arch 2 meters from the vertex of the parabola. So suppose up to here the distance is 2 meters, right? So this distance is 2 meters. We have to find here the width of the parabolic arch 2 meters from the vertex of the parabola. So let us denote this width by 2h. Then from here to here it will be h, and from here to here it will be h. Let us denote this point by P. So the coordinates of point P will be, x coordinate will be minus h and y coordinate will be minus 2. So we have assumed that the width of the parabolic arch 2 meters from the vertex is 2h. Therefore, point P with coordinates minus h minus 2 lie on the arch. That is, this point will satisfy equation number 2. So in equation 2, replacing the values of x and y, we have, in place of x square minus h square is equal to minus 5 upon 8 into y, that is minus 2. So this implies that h square is equal to 5 upon 4, which implies that h is equal to square root of 5 divided by 2. Now we have to find 2h, that is the width of the parabolic arch 2 meters from the vertex. Therefore, 2h is equal to 2 into square root of 5 divided by 2, which is equal to square root of 5 meters. Therefore, the width of the parabolic arch 2 meters from the vertex of the parabola is square root of 5 meters, or which is approximately equal to 2.236 meters. And this is the approximate value. This completes the solution. This question says that a cable of a uniformly loaded suspension bridge hangs in the form of a parabola. The roadway, which is horizontal and 100 meters long, is supported by vertical wires attached to the cable, the longest wire being 30 meters and the shortest being 6 meters. We have to find the length of the supporting wire attached to the roadway 15 meters from the middle. Let's begin with the solution. And this is the uniformly loaded suspension bridge, which is hanging in the form of a parabola, and from here till here, let this be the roadway 100 meters long. Now the suspension bridge is supported by vertical wires, the longest being 30 meters. So let this be the longest wire which are attached at the corners of the suspension bridge, and the middlemost wire is of height 6 meters. We have to find the length of the supporting wire which is attached to the roadway 18 meters from the middle. Let us denote this middle point by P. So if we move 18 meters towards the left, suppose this point is 18 meters from P, let us denote this point by N. So we have Pn is equal to 18 meters. Then we have to find the length of the vertical wire which is attached to the suspension bridge. Let us denote this point by M. So we have to find Mn. Let us draw a horizontal line passing through the vertex of the parabola, and the vertex of the parabola is the point O, having the coordinates are 0, 0. Let us denote these 2 points by A and B. So from the given data we can find the coordinates of A and B also. Now, since this distance is 6 meters and this hole is 30 meters, therefore if we denote this point by Z, then AZ will be equal to 24 meters. That is, from A to Z the distance is 24 meters. So the coordinates of point A are, x coordinate is minus 50 and the y coordinate is 24. Now as we can see, the bridge is in the form of a parabola which opens upwards. Therefore, the equation of the suspension bridge is given by x square is equal to 4ay. Let us denote this equation by equation number 1. Now, as we have discussed, point A having coordinates minus 50 and 24 lie on the suspension bridge, as we can see. So this implies this point will satisfy equation number 1. So replacing the value of x by minus 50 and y by 24, this will imply that A is equal to 50 into 50 divided by 4 into 24, and this is equal to 625 divided by 24. So this is the value of A. Now substituting, A is equal to 625 divided by 24 in equation number 1, which is x square is equal to 4ay. So we have x square is equal to 4 into A is 625 divided by 24 into y. So this implies x square is equal to 625 divided by 6 into y. Let us denote this equation by 2. Now we have to find the length of the supporting wire attached to the roadway, which is 18 meters from the middle. Now we have already supposed that the point N is 18 meters from the point P. So we have to find the length of the wire Mn. Now the coordinates of point M are the x coordinate moving towards the left from the point A is minus 18, and the y coordinate here is h, let us suppose it. Therefore, point M with x coordinate minus 18 and y coordinate h lie on the bridge. So that means it will satisfy equation number 2. So replacing x by minus 18 and y by h, this implies that h is equal to 18 into 18 into 6 divided by 625, and this is equal to 3.11 approximately. Therefore, height Mn is equal to, if suppose this point is L, then ML plus Ln, and ML is the h coordinate plus Ln, that is 6, which is the shortest vertical wire. So h is 3.11 plus 6, and this is equal to 9.11 approximately. Therefore, the length of the supporting wire attached to the roadway 18 meters from the middle is 9.11 meters approximately. This completes the solution. This question says that an arch is in the form of a semi-ellipse. It is 8 meters wide and 2 meters high at the center. We have to find the height of the arch at a point 1.5 meters from one end. Let's begin with the solution. And first let us draw the figure with the help of the given data. So in this figure, the upper part, let us suppose, is the semi-ellipse, which is an arch. It is 8 meters in width and 2 meters in height at the center. We have to find the arch height at a point 1.5 meters from the end. Let us denote the two ends by A and B. Now we have to find, suppose this is 1.5 meters from the end. So we have to find the height of the arch. So let us suppose this height as h. So this point P will have coordinate 2.5 comma h, since this hole is 4 meters, which is half of the width of the ellipse, and 4 minus 1.5 is 2.5 meters. So this distance is 2.5 meters from the origin of the ellipse. Now since the arch is in the form of a semi-ellipse, the equation of the arch can be taken as x square divided by a square plus y square divided by b square is equal to 1. Now from the question it is given that a is 4 and b is 2. Therefore, this equation is further reduced to x square divided by 16 plus y square divided by 4 is equal to 1. Or on taking the LCM and then cross multiplying, we have x square plus 4y square is equal to 16. Let us denote this by equation number 1. Point P, which is this point, lie on the arch. That is point with coordinates 2.5 and h lies on the arch. That is, this point will satisfy equation 1. So replacing x by 2.5 and y by h, we can get the value of h. So this implies 4h square is equal to 16 minus 2.5 can be written as 5 divided by 2 whole square, or now let us simplify this. 4h square is equal to 16 minus 25 divided by 4, which is equal to 64 minus 25 divided by 4, which is equal to 39 divided by 4, which further implies that h square is equal to 39 divided by 4 into 4, that is 16, which implies that h is equal to square root of 39 divided by 16. Now square root of 39 is somewhere near to 6.245 and the square root of 16 is 4. So this is equal to 1.56 approximately. Therefore, the required height of the arch at a point 1.5 meters from the end is 1.56 meters approximately. This completes the solution. This question says that a rod is of length 12 centimeters which moves with its ends always touching the coordinate axis. Determine the equation of the locus of the point P on the rod, which is 3 centimeters from the end in contact with the x-axis. Let's begin with the solution. And in this figure, let the coordinate axis be x and y, and AB be the rod of length 12 centimeters. Let us denote the point of intersection of the coordinate axis by O. Now let OA is equal to A and the distance OB is equal to B. That is, the coordinates of point A are A, 0 and the coordinates of point B are 0, B. Also we know that angle AOB is 90 degrees. Therefore, AB square is equal to OB square plus OA square. This implies that 12 square is equal to A square plus B square, which implies that A square plus B square is equal to 144. Let us denote this equation by 1. Now, we have to determine the equation of the locus of a point P on the rod, which is 3 centimeters from the end in contact with the x-axis. So this is the x-axis. Suppose this is a point P which is 3 centimeters from the end in contact with the x-axis. This means if PA is equal to 3 centimeters, then BP is 9 centimeters. So this is the rod AB such that AP is 3 centimeters and BP is 9 centimeters. So this implies that the point P divides the rod AB in the ratio of 3:9. Or we can say that 1:3. So this implies this is 1, this is 3. Now let us apply the section formula to find the coordinates of the point P. Let the coordinates of the point P be x, y. So x, y is equal to 1 into 0 plus 3 into A divided by 3 plus 1, and the y coordinate is given by 1 into B plus 3 into 0 divided by 3 plus 1. So the coordinates xy are 3a divided by 4,
b divided by 4. So this implies that x is equal to 3a divided by 4 and y is equal to b divided by 4, which implies that a is equal to 4x divided by 3 and b is equal to 4y. Now substituting the value of a and b in equation number 1, which is a square plus b square is equal to 144. So on substituting, a square as 4x divided by 3 whole square plus b square as 4y whole square, we get this equation. This implies that 16 x square divided by 9 plus 16y square is equal to 144. Now on dividing both sides by 144 gives 16 divided by 9 into 144, which gives 1 divided by 81 into x square plus y square divided by 9 is equal to 1. Therefore, the required equation of the locus of a point P on the rod is x square divided by 81 plus y square divided by 9 is equal to 1. This completes the solution. In this question, we have to find the area of the triangle formed by the lines joining the vertex of the parabola x square is equal to 12y to the ends of its lattice rectum. Let's begin with the solution, and first let us draw the figure. So in this figure, A, L, L dash is the triangle of which we have to find the area. Now the given parabola is x square is equal to 12y. Now we know the standard form of the parabola of this type is x square is equal to 4ay. On comparing the given parabola with this, we see that 4a is equal to 12 or a is equal to 12 divided by 4, that is 3. Now we know that the ends of the lattice rectum of a parabola are given by a comma 2a and a comma minus 2a, that is 3 comma 6 and 3 comma minus 6. So the coordinates of L dash are 3 comma minus 6 and the coordinates of L are 3 comma 6. Now the coordinates of the point L are 3 and 6. This implies that if this point is O, then OL is 6 and OA is 3. Now as we can see that ALO is a right angle triangle at O. Therefore, area of triangle AOL is equal to half the base into height. Let the base be OL, then the height is OA. So this is equal to half into OL is 6 and OA is 3. So 6 into 3, which is equal to 9 square units. Now we have to find the area of triangle ALL dash. So area of triangle ALL dash is twice the area of triangle AOL, right? Since AOL is half the area of triangle ALL dash. So this is equal to 2 into 9, that is 18 square units. Therefore, our answer is the required area of the triangle, as we have found out, is equal to 18 square units. This completes the solution. In this question, we are given that a man is running on a race course and he notes that the sum of the distances from the two flag posts from him is always 10 meters and the distance between the two flag posts is 8 meters. We have to find the equation of the post traced by the man. Let's begin with the solution, and first let us draw the figure from the given data. And in this figure, let us suppose that this ellipse defines the race course on which the man is running. So, let the equation of the race course be, as the race course is in the form of an ellipse, so its equation will be of the form x square divided by a square plus y square divided by b square is equal to 1. Now in this figure, let F1 and F2 be the two flag posts such that the distance between them is 8 meters, and let P be the point from which the man is noticing such that the distance PF1 plus PF2 is equal to 10 meters. Hence we are given that the distance PF1 plus PF2 is equal to 10 meters and the distance between the flag post, that is F1, F2, is 8 meters. Now see that if the point P is on the x-axis, then we have PF2 plus PF1, that is 2a. Therefore, this implies that 2a is equal to 10, and if suppose this O is the origin, then the distance between F1 and F2 is OF2 plus OF1, that is 2 times of AE is equal to 8. Now 2A is equal to 10 implies that A is equal to 10 divided by 2, which is equal to 5. And since 2AE is equal to 8, this implies that E is equal to 8 divided by 2 into A, and A is 5, so 2 into 5 is 10, which gives 4 by 5. Therefore, the value of A is 5 and E is 4 by 5. Now, we know the relation that B square is equal to A square into 1 minus E square, that is 5 square into 1 minus 4 upon 5 whole square. So we have 5 square into 25 minus 16 divided by 25, which is equal to 9. Therefore, B square is equal to 9 and A is equal to 5, so A square is equal to 25. Now, substituting the value of A square and B square in this equation to find the equation of the post traced by the man. Therefore, on substituting A square is equal to 25 and B square is equal to 9 in x square divided by A square plus y square divided by B square is equal to 1 gives x square divided by 25 plus y square divided by 9 is equal to 1. So, this is the required equation of the post traced by the man. This completes the solution. In this question we are given that an equilateral triangle is inscribed in the parabola y square is equal to 4ax, where one vertex is at the vertex of the parabola. Find the length of the side of the triangle. Let's begin with the solution, and first let us draw the figure with the given data. Now let, in this figure, this be the parabola, and let the vertex A of the triangle ABC coincides with the vertex of the parabola, and let B and C be the other two vertices of the triangle. Now ABC is an equilateral triangle, therefore each angle is of measure 60 degrees. Therefore this is 30 degrees and this is also 30 degrees. Also, as ABC being an equilateral triangle, the parabola is symmetrical about the x-axis. Therefore B and C will have the same x coordinate. Let the x coordinate be taken as h. So the x coordinate in both the cases is h. Now let us suppose that this point is P. Then CP divided by AP is equal to tan 30 degrees. This implies that CP is equal to AP into tan 30, that is h into 1 upon root over 3. So which is equal to h divided by root over 3. Therefore the y coordinate of the point C is h divided by root over 3, and the y coordinate of the point B is minus h divided by root over 3. Now this is the parabola y square is equal to 4ax. Now as we can see from the figure, point C with coordinates h and h upon root over 3 lie on the parabola given to us, which is y square is equal to 4ax. Therefore this point will satisfy the parabola, that is h upon root 3 whole square, replacing y by h upon root over 3 and x by h, we have this is equal to 4a into h. So this implies that h is equal to 4a into 3, which is equal to 12a. Therefore h is equal to 12a. Now according to the given question, we have to find the length of the sides of the triangle. Now as we can see, the lengths of an equilateral triangle are equal. Therefore let us find the length of BC. And BC is, as we can see, 2 times of CP. And CP is nothing but h upon root over 3. So we have 2 into h divided by root over 3. Now let us substitute the value of h. So we have 2 into 12a divided by root over 3. Now rationalizing the denominator, we have 24 root 3 divided by 3 into a, which on simplifying gives 8 root 3 into a. Therefore, the length of each side of the inscribed triangle in the parabola y square is equal to 4ax is 8 root over 3 into a. This completes the solution.